In the former textbook, that's what they wrote there. Method of charging insulator. So what are insulator? Like we said earlier, insulators are material that does not conduct electricity. So but we can make these materials to have a particular given charge, either a negative charge or what a positive charge. Okay, and basically there are two methods, but some textbooks or the O-level textbook says there are three. And what are these three they mention? They mention frictional method, they mention the Alright, so welcome to the part 3 of our classroom lecture on electrostatics. Okay, electricity and magnetism by the young Modulus. Okay, so this is for us, our states and the federal university students who are making use of this textbook. Okay, and like I said, the cover may be different, but the concept remains the same. So you can always check the scheme of work. I think I didn't do that, so you have the scheme of work here with you, so everything remain the same. Okay, everything remain the same. All right, so the part 3 of this video of our lesson today, we'll be looking at charging by conduction and induction, charging or method of charging insulator. Some in the former textbook, that's what they wrote there, method of charging insulator. So what are insulator? Like we said earlier, insulators are material that does not conduct electricity. So but we can make these materials to have a particular given charge, either a negative charge or what a positive charge. Okay, and basically there are two methods, but some textbooks or the O-level textbook says there are three. And what are these three they mention? They mention frictional method, they mention the charging by conduction, and then by induction, or what we call electrostatic induction. Now what you need to understand is that frictional method and conduction method are classified as one. Why? They're classified as what? Contact methods. So basically we have two types of charging, and these are what? Contact and non-contact. Now under the contact method, we now have the conduction and frictional method, while under the non-contact, we only have charging by what? Electrostatic induction, because there is no contact between the charging and the charged body. Okay, so these are things that we need to grab in this concept. Now let me explain the contact method before we now dive into the non-contact method. Now in the contact method, we have the two objects first coming in contact. Okay, and of course the frictional method and the conduction method, they have to do with the contact methods. Now just like the frictional method, of course, as we all know, the two objects brought together and they are rubbed vigorously, and of course there's a transfer of charge. Okay, now let's just look at it the right way around. The conduction method, the two bodies are brought together but they are not rubbed, but with time there's a transfer of charge. Now let me use the concept of our magnets to explain that conduction method. Okay, now we all know that if you have your magnets, like if you go to all these tailors, those who are so close, you discover that they have this kind of big magnets. They always have it. And those magnets, the essence of that magnet is to bring all their metallic buttons or pins or whatsoever thing together, you understand, so that they can easily get them and they will not just get missing. Do you understand? They will just keep it somewhere there. They can always get them. Now you notice that if you keep a particular magnet or a particular metal, nail or something, pin, metallic material on that magnet, when the magnet or when that pin stays there at that on that magnet to a particular time, depending, maybe a week or two, a month, a year, or years or so, you notice that by the time you remove that magnet, by the time you remove that pin, that nail, or that metallic button or whatsoever, that material tends to have a magnetic property. You've observed that. If you've not observed that, you can always check that. So it's an assignment for you. So you notice that the object tends to have a magnetic property. Now what does that actually mean? There was no rubbing, there was no like frictional stuff there, but the thing stays there. So with time, okay, it tends to have that magnetic property due to contacts. So you can see that there's a contact there, right? But there were, you just conduction, like in our heat transfer conduction, when you put water, hot water in the cold water, before you know, the whole thing mix up. Is that become cold or become hot, depending on which of them has a higher quantity, you understand? So they mix up. Okay, there's just a transfer, molecular transfer of energy. Okay, so that's exactly what happened in conduction method. Okay, but there's still contact. That's what we classify them as contact method. You understand? So in the frictional method, we also have a case where you don't just keep it, but you rub it. So that's just the difference between the conduction and the other method. So these are the same. So now one thing that is very common about these two classes of contact method, friction charging method is if actually wants to get a positive charge, then I have to use a positive charge to rub or to drop, or I have to drop that object, that insulator on a positive charge. So what I get is going to be positive charge because I work with a positive charged object. Okay, the charging and the charged material will give me the same thing. Okay, what I mean by the charging is the one that you are trying to work, and then the charged one is already one that is already charged. Okay, so now if I also want to get a negative charge, I have to bring a negative charge object with the insulator and rub together, or I'll bring them together until there's going to be a transfer of charge. Okay, molecular transfer of charge, which is the conduction method, or by rubbing it vigorously and I have that out. Okay, so now yeah, that is it. Now in the induction method, let's look at the induction method, and then later on I'll look at the similarities and then the difference between these two kind of these two type of charging process. Now in the induction method, now you can see it here, induction method. Like I said, I don't want to stress myself more because I'm working directly with this textbook, so I'm just trying to see how I can explain this textbook very clear to you. Alright, so look at induction method, look at the process, look at the various stages of induction method here. Okay, in your material, in your textbook here. So now induction method, like I said, in the induction method there is no physical contact between the two objects. There's no physical contact between the two objects. So in this case you have an object mounted, the charged object mounted on an insulating stand, and then the other one coming closer to it. There's no contact. So electrostatic induction is a way of charging an insulator without physical world contact. Do you understand? So now you bring the object, you look at stage 1 here, they say separation of charge. So you look at stage 1, they have been lettered A, B, C. So you can look at the stage 1, right? So you can look at the stage 1 there. So in the stage 1, you look at it here. So we have the separation of charge. This is the insulator, this is the charged material, and this is the insulator. Okay, insulator is this circular object here that is being mounted on the insulating stand, and this is the charged material brought closer to it where there is no contact. And if you look at the section B, they said sphere is connected to ground. Sphere is connected to ground. Now what really happened is that if you observe very well, there is a kind of separation of charge, in a sense that this object is positively charged. Okay, now this object is positively charged. What happened is that it's going to repel, because an insulator contains equal number of electron and one proton, or equal number of charge. You understand? Is neutral. An insulator is neutral, is electrically neutral. So but when you bring a positive charge object, see what is going to happen there. You notice that this positive charge object is going to repel every positive charge in that very insulator. Okay, and then attract every negative charge to it. So that's what is happening there. So it's going to attract all the negative charge towards it, and then repel all the positive charge towards the other end of the object. Okay, so you can see that now, because we want to get rid of the positive charge, so there's something going on there. We are bringing a positive charge, and then the positive charge repel all the negative charge towards the other side, and then we want to get rid of the other negative charge. So you notice, all the positive charge. So you notice that it's going to be what we call earthing. So is either you touch it with your hand, which is not safe, or you collect the earthing material. I'm going to explain something on earthing, and of course I'm going to tell you the importance of having an earthing in your building, what we call a thunder arrestor in your building. And of course I can tell you, I think I shared this with some of us, that one of the thunder that blew, I think that was June, July or something, really damaged my system. In fact, my flat screen, okay, my television here. So in fact it was very, very terrible. So I'm going to show you why you should, even though your building is not being earthed or grounded, then what you should be doing, okay, especially when it is raining season, and why you should guard against some of those things. Because whether you connect it or not, whether you connect them or not, the thunder arrestor, in fact I'm going to teach you the concept of thunder arrestor, what really produces or what really causes thunder. I'm going to actually explain that. So if I've forgotten doing that video, please remind me in the comment section in any of my videos. I'm going to be reminded, and then I'll do that. So you notice that this is section B, okay, stage B. Now look at the stage C. Sphere is disconnected. Sphere disconnected from the ground. Now what's the essence of doing this? The essence of doing this is to remove, the essence of this grounding is to ensure that this positive charge, the excess positive charge, goes down to the earth, because we want that charge to be negatively charged, and that's why we draw a positively charged object. So once you've done that, the negative charge object, the positive charge go to the earth, and then you now remove the earthing. Why? Because if you keeping the earthing and you remove the other charge, this thing, which is the other one, then this will come back again. So it's not that okay. So you need to remove it, and once you remove it, as soon as you remove it, you remove the other charge in this thing, and then the system spread, the negative charge spread. So what can we say in this section? We notice that our negative charge is produced when we bring a positive charge. So the charging and the charge system, the charge object and the charging object and the charge object are opposites. But in the other method, the contact method, which is the friction and the conduction method, they were the same. But here, if you want to charge something negative, you have to bring a positively charged object. While if you want to charge negative, you have to bring a negative charge. If you want to charge positive, you have to bring a negative charge material. Okay, so this is what the induction method holds. You understand? So, and of course, the magnitude of the charge produced also depend on the process carried out and how long or what really happened in between the process. Do you understand? That's what also determines the magnitude of the charge that is being produced. So basically, like I said, there are two types of charging process: the contact and the non-contact method. Okay, so the major difference here, like I mentioned earlier, the major difference here is that in the contact method there is contact, of course, while in the non-contact, in the induction method, there is no contact. Then secondly, in induction method, if you want to charge something negative, you have to bring a positively charged material, and vice versa. But while in the contact method, which is the friction and the conduction method, they are the same. If I want to get a positively charged from insulator, I have to bring a positively charged material. If I want to get a negatively charged, I have to bring a negatively charged material. So it's just the same. The charging and the charged object are all the same. Okay, so this will be the end of this part 3 of this video. So in our next concept, we are going to look at measurement of quantity of charge. How do we know the type of charge? How do we know if I actually want to, maybe if a particular charge body is not known, and I want to know what kind of charge that this object have? Does it have negative charge or positive charge? I want to actually know. How do I know? How do I know the quantity of charge contained in that object in case I want to use it for practical work in the electricity lab, physics lab? Okay, so these are what we need to know, and that is the concept of gold leaf electroscope. So I believe you must have heard more about that. I'll tell you the working principle, how it works, how do we know, how do we detect a particular charge, what is the action of the leaf, and then and so on and so forth. If you have a negative or positive charge, what actually happens there, we'll discuss that. And also we are going to also discuss charge quantization, and that will lead to our first calculation we are going to have. How do we calculate total number of charge in a particular system of an object? So we'll also look at that. Like I said, I'm following the textbook accordingly. And then the last part, the last two concepts, or the last 3 videos we are going to be having after this next one, this part 4, okay, is going to be Coulomb's law and electric field, the electric field properties, okay, electric field lines also. So we'll discuss this. So we have about 4 more videos to have, excluding the calculation, okay, but if possible I can include the calculation all together. See you in the next video.
I still got joy in the I've got things that make no sense. Now we're going on.